So welcome back to my video. Last time I have shown this code here that you can use to control the LED by using serial monitor, and in this code I just send characters, the 1 and 0. So if let's say I remove this code here, which I change into serial.print9 as usual to look at the data that we send, just like that, and then let's say I directly upload this code or compile this code, and if we try to send a data more than for example, if I want to send a data for PWM 255 for example, so if we click enter, as you can see it actually transmitting 2 and then 5 and then 5. It not transmitting 255 because character is just a single character, meaning that 2 is a single character, 5 is a single character. It cannot transmit more than that. If you want to transmit more than that, you can't use character, meaning that let's say if I want to transmit other words, like this one here, so see, it is not only transmitting the whole words, but it actually transmitting I, and then it transmit K, and it transmit H, and until the end, which means again, if we want to transmit more than just a single digit character, you can't use these codes here. In other words, that's why it is not defined as integer. Instead, it is defined as character. So how to transmit integer to the Arduino, and this will be discussed in detail in this video. So to make this part here interesting, so I will use this Tricolour RGB LED here. So if you can see here, this LED here has 4 terminals, which actually can produce 3 different colors. This is why it is called the RGB LED or Tricolour LED. So RGB, why? Because it will give the values of red. So this part here, the longest part here is the cathode terminal, which as usual will be connected to the ground. But there are 2 types of RGB LED actually. This is a common cathode, which means one cathode only. There are also another Tricolour RGB LED which have a common anode, which means that it has one anode terminal, which will be connected to the power supply, the 5 volts, not to the ground. So make sure you check your LED. So this one here is basically the common cathode, which means that this longest terminal here is the cathode terminal, which will be connected to the ground, and then it has 3 more pins here, which besides the longest one here at the end sides here is the red color. So if you connect with your Arduino and you control this, you make these pins here high, this terminal here high, you will produce the red color. And then we have the green color. Besides this cathode terminal here is the green color, RG and B. B means that the blue color. The end sides here at the end of this terminal here is the blue color. So red besides the cathode, and another at the center is green, and at the end is blue. So if you have this Tricolour RGB, so you can check this. Make sure you can refer to this video where this longest one is cathode, and then here is the red color. Besides the cathode, here is the green color, and at the end is the blue color. So this is the RGB LED. So we will use this RGB LED here in our circuit. So you can construct this circuit here. So I will show this circuit. Basically it's the same circuit as before. The difference is I only change this LED. Instead of I use this LED, previously I use LED, normal LED, connected to pin 11, but now I change with this 3 color LED, and then the red colors goes to pin 11, the blue colors goes to pin 10, and the green color goes to pin 9. So you can follow this connection to the Arduino. So again, if you need time, you can pause this video first, and if you want to connect with the by using this TinkerCad here, basically it already stated which pin is for the red, which pin is cathode, blue and green. But the best thing is, if you want to improve your skill, the circuit skills, the circuit connection skills, use the hardware. If you want to improve your circuit simulation skills, use the Proteus. So anywhere, any software you use, as long as you improve some skills, is good. So again, just take your time. It's up to you how long you want to take your time. You may pause this video, and when you're ready, as usual, then you click play buttons again. So now you may pause this video. So if you have done connecting your circuit, constructing your circuit, as usual, let's go directly to the Arduino IDE. So let's start programming. Now, as you can see in my Arduino IDE here, I already have these lines of codes here, because I'm quite lazy to rewrite it again for you. But again, you can just refer this. As usual, you can pause this video if you need to. Basically what happens here is the same thing. Whatever that I have mentioned in the previous video, I will not repeat again. That's why I already have these codes here, so that you don't need to wait for me to write the code and you will be bored by this video, this lengthy video here. And that's why I already construct these lines of codes before. So here, what you see here is basically this part here is to define the pins as usual, which is a constant, with the red LED is at the pin 11, green at the pin 10, blue at pin 9. So this is depending on your connection. So if you follow the previous my connection in this TinkerCad here, so basically that's why it's 11, 10 and 9. So here is 11, 10 and 9. And then we have these variables for the RGB level, because we want to change the value. We want to give whether it is a 0 value to until any value in between 0 to 255, because we want to control the brightness. And that's why again we use the pin number 11, 10 and 9, because this is the PWM pin. So don't use 8, don't use 7, because these two pins cannot be used to control the brightness. So make sure you use the pins with this curly, the wavy symbol here. So again, that is what this two lines here means. And we go to the board setup. As usual, we want to control the Arduino using serial monitor, and therefore we use serial.begin 9600 baud rate. And then also, as usual, what we have seen so many times, we define the output ports, all the 3 LED ports as output ports. And that's why I won't rewrite this code again. But if you need to rewrite this code again, feel free to pause this video and rewrite it. And then if you are ready to proceed, just play again. So now if you are ready, then we will move to the void loop. So let's go to the void loop. We will start to program our Arduino. So here the functions that we want to use, before this I used if serial available, but now I use while, meaning that as long as the data is transmitting, it will do this loop here until the end of the until we stop transmitting the data. So what we will do here, basically we want to get the integer value. Before this, in the previous video, we only send the character, but now we want to send the integer. So we want to get the integer value. So what we can do here, and this integer value will be converted into the R value, the G value and B value. So R value will be based on the whatever that we put in the serial monitor. We need to pass the integer, so pass integer. That's why that is the coding. Pass integer. Make sure the I is capital letter. Pass integer. So what does this do is it search for integer in the lines, in the information that we give in the serial monitor, and then it goes to the next value. It search for another integer. So again, because I'm quite lazy, I just copy and paste. And the second, it will search for the second integer, which is the G value, and then the third integer, which is the B value, the blue value. So that's it. Meaning that this value here, this is the only codes that will be introduced in this video, which it is actually it will find the first integer value, first integer, and then it will go to the second valid integer. If it could find another integer, and then it will go to the third valid integer. Meaning that if let's say if you give inputs that is not integer, if you give characters, A for example, or comma or space or semicolon, that is not integer, and therefore it will skip until it finds another integer, and then it finds another integer until the end, until you click enter, which means that you need to separate these three integer by using any other characters. It's okay, because it will skip that character, and that character will be the to differentiate between integer. So now if it so again you can hear what I say now, if, meaning that there will be if statement here. So if, let's say since after we give 3 characters, we click enter, meaning that if the serial dot read, it read the value is equals to \n or next line. If you never know about the \n before, the \n is the next line, or meaning that we have clicked enter, it done transmitting. So what it does here, it will go to this if statement here. So in other words, after we click enter, we will start doing this function. So it receive the integer first. After clicking enter, then it will do this statement inside the if statement, which we know what we want to do. We want to send this value into the LED, which means we want to write the LED with different values of PWM. And to write in PWM, we cannot use digital write. So what we need to use? So you can think for a while, or you can directly write in your program. If you want to try your knowledge so far, you can just pause this video, you complete these lines of codes, the next lines of codes, and then recheck again. After you type the codes, you can recheck again. We want to to turn on the LED by using the PWM value, meaning that we will use what? So again, you can pause this video if you want. If you don't have idea, we will use not digital right, but we will use analog right. So if you don't have any idea, so this is what we will do here. So analog right with the for the pins red, the pin red with the value, it must be the value of R value. So that's it. Okay, so this is for the value of red, which means for the next lines of code, the same thing, we will write everything consecutively, not one after another. So that's why there is no delay. It will done everything all together, which means again after red is green, hot green, obviously with the green value, and with the final is blue with the blue value. That's it. As simple as that. So this is from the analog right, from the PWM. If you never know how to use PWM before, feel free to watch the PWM videos that I did previously. So the link, you can follow the link down below. And the others are what we have covered so far. So this is what we have covered so far. All the codings above here is what we have covered so far, so that's why I just go fast. The only parts that is related to this video is only this part here, the pass integer, to find the integer and then transmit that integer. So that's it. This is the only codes that you need to know how to transmit integer, not just a single character. So as usual, after you have done this code, we can connect our Arduino, and then after that we can recheck Arduino Uno, COM number, and upload. If serial.read apa ni? Okay, sorry, I'm missing one more equals, because it's not equals, it is actually a boolean, which means it needs to compare is this characters if it reach the end of the transmission or not. So because of the comparison, we need to use this equals sign. Sorry for that, I missed one equals there, and then we can rewrite again and it'll be okay. One more, sorry again, one more, bbell. Right. So now everything is done uploading, meaning that there is no error. So as usual, we can test it. Click the serial monitor. Click the serial monitor. So how we want to do this? As I said, they will search for the previous the first integer. So let's say the first integer is 255, because PWM is 8 bits. The maximum is 255, and then next the second, we will find the second integer, meaning that we need to differentiate between these two integers, and therefore we need to classify it by using different characters, so that it will find the characters, and then it will skip the character. Which means we can use any character. For example, for me, maybe I just use comma here. You can also use full stop, you can also use colon, semicolon, curly brackets, or whatever, to differentiate between two integers. So the second integer maybe also 255, and then the third integer is also 255. Notice that I use different characters there. It doesn't matter because we just want to differentiate between the first integer, second integer, and third integer. So that's it. So what we will do here, as usual, just click enter. When it receive enter, meaning that it will be goes to next line, so it will stop transmitting, and it will start to write the RGB value. So let's enter. So enter. Now you see here the RGB LED is brighten up at the maximum values, which producing the white color. So this is how you transmitting the PWM value. So let's say if I want to just lighting up the red only, so just 255 and the others are 0. If I want to transmitting the, if I want to turn on the green only, so we can use 20255 0, since the second value is green, so it will turn on green only. And finally, if I want to let's say brighten up the blue only, so 00255. So this is the maximum value, the maximum lighting. Okay, so meaning that everything is went well, but we don't really sure what happens inside it. So maybe we can basically we can display it here as well. So to display it here, so just add in this if statement, just add serial print. For example, I just use serial dot print for the red color. Print for the red color. So red color space, and then it goes to the serial print. So it's too long, so I just copy and paste as usual, so that you won't get bored. If you feel this is too fast, this time around I goes too fast, so you can just slow it down. The YouTube video can slow it down, so you can just slow it down. You can pause every part that you want. So red, and then it will display the red value, R value, and then it will goes to the next green value in the same line. That's why I did not use print line here. Green with the separation of comma here, with the green value, G val, and the final is blue with the B value. So B value, so that's it. And then we will go to the next line, so print line, B value. So now we should be able to see what really happens, what values we really transmitting. And to test this, as usual, just re-upload again. So let's open this serial monitor. So maybe you quite you don't know what values you want to give. So let's just open, for example, I open this PowerPoints here with nothing. So let's just open a shape, draw a shape, insert a shape. So just a single shape, and then goes to shape fill, go to more fill color. So as you can see here, it has different values of RGB. So we can use this as our guideline. Just rearrange this first. Okay, so for this color here, this blue color is R68. So 68, and then 114, and then 196. So 196. So now we can see the colors that it produces is actually this color, but maybe my video is not quite nice because it too bright and therefore you can't really see the color. Let's say I want to have this almost pink color here, so that it will give 2 to 6, 2 to 6, 3, 8, and 2 to 6. So it will give almost like a red color there. But again, because my video is not quite nice, so you can't see it nicely. So but if let's say if I cover it like this, so as you can see, it's almost like the color that I shown you. So now maybe we can try one more color. I think somewhere in between. Okay, for example, this color here, 45. So 45, 198, and 219. So you can see here you get this cyan color here, and maybe one more, last one, maybe like a goldish color here. I don't know what color is this. So 216, 184, and 48. So this is how you want to play with this color. So now as you can see, the color is so see, the color is just like the in what you see in the screen. The almost like the I don't know, the what is it, the goldish, I think. I'm not sure. So this is how actually not you only learn the programming, but actually what I show here is how does the pixels in the computer works. So as you can see here, the color is changing with this RGB value here, which is displayed on your screen, which is almost similar like what we see in the LCD, in the LED. So if you want to see it clearly, you need to cover a little bit, like I shown just now with your hand or whatever, or paper for example. You can use anything to cover a little bit to see how they mix the color. And when everything is brightened up at the maximum color, 255, 255, 255, like I shown in previous parts, so it will brighten up to white color, the maximum white color. So here is how the white color generated in our screen, which is actually it is constructed by this RGB LED. There is RGB color with very small pixel, very small RGB colors, and this make up 1 pixel. So 1 pixel have these three colors, and when it brighten up at the maximum brightness, it will display this white color here. So it is not actually white, it is actually red. The combination of red, green, and blue with a maximum brightness, it becomes this bright white color. And for this goldish color, it is actually the combination of this 216 red color. The brightness of the green is just 184, and the brightness of blue is just 48, and so on. So basically how the computer changing color is by changing this brightness of this color, each of this color here. And I think that's it. That is how actually we transmit this color here to our Arduino, and how to display it. So now we can see the value that we actually transmitting. And I think that's it for this parts here. That's it. If you have any question, any problem, anything that you confused, as usual, feel free to ask me in the WhatsApp message or wherever you think you want to ask me, in the group message. And hope you learn a lot from this video, hope you understand, especially hope my effort here is not going to waste. Feel free to share this video if you think it is beneficial for you. So just share this video to those who need to learn how to do this. And as usual, if you like this video, give us a thumbs up and consider yourself subscribing to this video, or maybe asking someone else to subscribe as well. And that's it from me. Stay safe, stay curious, and stay joyful. I'm Ikhwan. May God bless you. Assalamualaikum.